right, the area of a rectangular window. All right, here we go again. Area of a rectangular window. So area is length times width. Kind of sounds familiar, okay? The area is 5x squared minus 10x square feet. If the width of the window is 5x, find the length. So I think this almost is a remake of the last lesson. Let's take a look. This is 5x squared minus 10x. The length is, we don't know. Again, the width is 5x. Okay, so we want to solve for the length, so that means we're going to have to divide by 5x. Well, we already know how to do that, okay? Because we know from before, the last lesson, that we're going to take each term and divide it by the 5x. And we're going to get x minus 2. And that's the length. X minus 2 feet is the length. Now, here's the part I really care about. I care about all of that, but here's the part I really care about. 5x, we just proved that 5x times x minus 2 is, right, 5x squared minus 10x, because that would be almost a check we would do. I want to say a couple of things. Okay, these are factors, okay, and these are terms, okay. So this is the product. This is the product of this. Sometimes we're given the product and we want the factors. One way to do that is to already have one or two of the factors. You already had two of the factors of this, and you were able to divide to get the other factor. For instance, if I tell you that 30 is the product, and I know one of my factors of 30 is 5, what is the other factor? You would have to go, well, 30 divided by 5 is 6. The other factor is 6. So when you have the product and you're going to the factors, that's called factoring. And what is factoring? Factoring is division. That's so important. Factoring is division because it gives us a goal on what we have to do. Later you'll see that there are some problems that are hard, not hard, but look long. And the first thing we have to understand is that factoring is division. Okay, but in order to factor, the easiest way to factor is to try to already have one of the factors. One way to have one of the factors is to get what we call the GCF, or the greatest common factor. Let me show you how that works. All right, let's take a look. It's absolutely going to be imperative to be able to get the GCF. In a list of numbers, the GCF is the biggest number that divides into all your numbers without a remainder. So for 30 and 45, okay, it can't be bigger than 30 because it's got to be able to divide into those numbers. But 30 doesn't go into 45, but 15 does. 15 is the biggest number that divides into both 30 and 45 without a remainder, because 15 goes into 30 twice, 15 goes into 45 3 times. It's also important to know your multiplication table. Okay, so the GCF, or the greatest common factor, is 15. Okay, for this one, the biggest it can be is 4. Because it can't be any bigger than your smallest number. So 4 does go into 40. Does 4 go into 72? 4 does go into 72, doesn't it? Yep, 4 does go into 72. So the GCF is 4. And it couldn't be any bigger than 4. Okay? It's not 2. 2 is a common factor, but it's not the greatest, the biggest one that divides into all of them. So that's how you do it for the numbers. Okay? For the letters, it's a little different story. It's actually easier. For the letters, you actually use the smallest exponent of the common base. Here's why. I'm going to show you right here why. Y to 5th, Y to 4th, Y to 9th. Y to 5th, Y to 4th, Y to 9th. These are factors. Y to 5th. I can write them as factors because I attach by multiplication, right? That's what it means, Y to 5th. I'm going to get in trouble for Y to 4th. I feel it. Y to 9th. 7, 8, 9. Okay. We want common factors. Well, they have 1 in common. They have 2 in common. They have 3 in common. They have 4 in common. That's how many they have in common. Since you want them to have common factors, the truth is you need the smallest exponent of the common base. So you look for the base. It's y here, only y. And the smallest exponent is 4. So that's the GCF. The smallest exponent of the common base. Okay? All right, let's look at number 4. In number 4, this is one expression, this is another, this is another. So I would go letter by letter. Does everybody have an X? Yep, everybody has an X. So x is going to be part of your GCF. But now we have to just pick the smallest exponent of the x. X here is 3, x here is 2, x here is 4, so the smallest exponent is 2. Does everybody have a y? Yes, everybody has a y, so y is going to be part of it. And the smallest exponent is a 1, so it's y to the first power. Does everybody have a z? Nope, this doesn't have a z, so it's not part of the greatest common factor because they don't all have them. They're not in common. So that's how you get the GCF. Sometimes you have letters and numbers, sometimes you just have numbers, sometimes you just have letters. So let's look at a couple of examples together. All right, we're going to go through this a little slow, the greatest common factor of terms, because if you can't do this, you can't factor. Okay, so these have commas because we're thinking of these as separate terms. When we really do a polynomial, they'll be separated by plus or minuses. Okay, so we're going to look at the numbers first. Look at the number. We have 3, 6, and 12, and we have to look at for the greatest common factor. Remember, it can't be any bigger than the smallest number because it's got to divide into those other numbers. So I would check the 3. 3 divides into 12, divides into 6, so 3 is it. Now go to letter. Does everybody have an M? Yes, everybody has an M. M has loads of friends. M to the first power is the smallest exponent. Now look for the N. Does everybody have an N? Yes, everybody has an N. Smallest power is a 1. So the greatest common factor there is 3mn. And there's actually 3 factors there. Okay, so that takes care of number 1. We're going to go fly here to number 2. All right, well, I'm going to go here. Here's why. If it has to be in common, it has to be in common with this. Does 2 divide into every single term? No. 2 doesn't divide into 3 or 17. And it doesn't have a letter. So there's no GCF here. No GCF. Try to get you. All right. I find 3 and 4 needs plenty of explanation, especially 3. Because I know what you're tempted to do. What you're tempted to do here is you're tempted to multiply this. But remember, we're trying to get the greatest common factor. That means they have to be attached by multiplication. These are attached by multiplication. Don't make them not be attached by multiplication. So 7 is a factor, x minus y is a factor once. And always think of parentheses as one whole thing. So 10 is a factor, x minus y is a factor once. So let me show you how I would do this. I would look at the numbers first, 7 and 10, and there's no common factor between 7 and 10, no number that divides into both of them. Then I would look at that whole thing. I can't look at just the x because the x is not a factor. The x is a term because it's attached with a minus. I can't look at the y, but I can look at the whole x minus y. Well, I do. Everybody has an x minus y. So x minus y to what's the lowest exponent? 1. So the GCF is x minus y to the first power or just x minus y. And that is the GCF of that problem. Okay? So, let's walk over to 4. Come on, walk with me. Okay, we're walking over to 4. I'm looking at the numbers, the 6 and the 12. We look at the 6. 6 goes in at both of those, so the part of our GCF is definitely the 6. Now, we can't look at the x, just the x, because that's not a factor. That's a term. So I have to look at the entire thing, x minus 3. I know that's going to be part of my GCF because they both have an x minus 3 as a factor. But here I have it twice. Here I have it once. I got to look for the lowest one, so it's 1, the lowest exponent. So my GCF is 6 times the quantity, x minus 3. I don't need that 1, probably wouldn't see it. And that's it. I would not multiply this out. Okay? It just makes our problems easier later. Okay. In this next set, 1 through 4, I'm going to ask you to do these, get the GCF. That's all I'm asking you to do. Now, these are separated with plus and minus. All that means is be careful about your terms. So in the first one, 10x squared is the first term, negative 5x is the second term. Look for a GCF for those 2 terms. And then try that for 2, 3, and 4. Click back on the video when you're ready. I hope you notice we just keep growing. Now they're written in a polynomial form. Okay, so 10x squared minus 5x. I look at the numbers. These are my separate terms. This is a term. This is a term. 5 goes into both of them, so my GCF, the number is 5. They both have an x. The smallest exponent is just 1. So my GCF for the first one is 5x. All right? Let's check the second one. GCF. This is a term, this is a term. 12 doesn't go into 30. So I have to use a number smaller than 12 because it's got to go into both of them. How about 6? 6 goes into both 12 and to 30. In fact, it's the biggest number that divides into 6 and 30. And now they both have an x. Smallest exponent is 1. They both have a y. Smallest exponent is 2. So it's 6xy squared. That's the GCF. All right, that's all we're doing. All right, let's play here. Here we go. There's no number in common because this is a 1, okay? So there's no number in common, so there's no number for this GCF, okay? I look at my variables, x cubed and x. So I know I have an x, smallest exponent is 1. Y squared, y fourth, they both have a y, so I need that. Smallest exponent is 2. So that's my GCF, x, y squared. All right? Let's check this one. Well, I'm going to go to the 2 because it's the smallest number. I can't use the 2 because of this silly 3, okay? I can't use an x because this doesn't have an x. So again, this has no GCF. And once you can pick out the GCF, then you're ready to start learning how to factor. So I think we're ready. Okay, we want to finally factor. So we want to factor this completely until we cannot factor anymore. We'll talk about what that means. Okay, so the first thing we do, the very first step, if you read it, is to find the GCF of all the terms. So there's 3 terms, all 3 terms. So to find the GCF, we look at the numbers. 2. 2 is the smallest number. I'm going to start there. Yes, 2 goes into all of those. So 2 is part of my GCF. I have no letter in common because 6 has no letter. So that's the GCF. That's the first thing we do. If we have a GCF, step 2, we write it down, and then we make a big set of parentheses. Now, our third step is we divide, which is why we just learned how to divide. We divide each term by the GCF. So we divide this by 2, this by 2, this by 2, putting our answer in that parentheses. So that's n squared minus 2 goes into 12, 6n plus 3, and now you're done. Let me explain why you're done. Okay? First of all, we have 2 factors. This is a factor, and this is a factor. Okay? You're done because if I go inside my parentheses, my terms have no more GCF, so I cannot factor this anymore. So we're done. Here's how you can check. You can always check factoring by multiplying. So I'm going to check it for you in my head. So this is what's going on in my head. I'm multiplying, distributing. 2n squared minus 12n plus 6, which is exactly where you started. So that's how you factor. Look for a GCF. Look for a GCF. Write down the GCF. Make a big set of parentheses. On the next slide, there are 4 examples. I'd like you to try to do 1 through 3. I will do number 4. All right, hey, I helped you here. I told you not to go there by yourselves. Here we go. First step is to look for a GCF. Remember, I would go to the smallest number because it can't be bigger than the smallest number. So 6 doesn't go into 9, so that's not going to help me. But what about 3? 3 is the biggest number that divides into both of them. So 3 is part of my GCF. Now A, not everybody has an A. He doesn't have an A. B, nope, he doesn't have a B. So B is not part of my GCF. C, yes, everybody has a C. And that's to the first power, to the to the second power, to the third power. So the smallest one is just C to the first power. That's my GCF. So I write it down. So that's my GCF. I'm just going to make sure you understand that. So my GCF is made up of these 2 factors. Okay, these 2 factors. That's my GCF. Now I'm going to divide each term by 3C. Now do you understand why we did that division step before? I don't want to cross it all out. I just want, it looks kind of sloppy. 3 into 6 goes twice. A squared stays, B stays, C is gone. Plus 3 into 12 goes 4 times, A cubed C, because one of the C's are gone. It's okay. Negative divided by a positive is a negative. 3 into 9 goes 3 times, B stays, and then we get C squared. And that's it. That is my, those are my factors. So here's what we got. We know we're done. We know we're done when everything's attached by multiplication. So we have 1 factor, 2 factors. This whole parentheses is the 3rd factor. The only terms that exist are inside the parentheses, and they have nothing in common. Notice 2, 4, 3, nothing in common. Nothing in common with Oh, no, right. Oh, I thought I had an extra C there. Good thing. Little blind. And nothing in common with the letters. This doesn't have an A, this doesn't have a B, this doesn't have a C. So we are done. And again, we could check by multiplying back. Okay? That's how I can check. If I multiply this back, I will get this up here. Okay? So that's number one. Let's do number two. Okay, I have a 3. Well, 3 doesn't go into 5, so that's no good. I have X, he doesn't have an X. Y, he doesn't have an Y. So this is no GCF. So for now, the only way we know how to factor is through this GCF method. This is not factorable. When something is not factorable, it is called prime, because it is not factorable. Let me explain why. Remember what a prime number is. A prime number is a number whose only factors are 1 and itself. And the only factors of this are 1 times this. That's it. The only factors of this are 1 times itself. Okay, this is an interesting one. This is a little different. This has got a negative first or negative leading term. We call this the leading term because it's first. Okay? Whenever you have a negative leading term, it would be a good idea to factor out the negative with your GCF. Okay? If you don't have a GCF, then you factor out a -1, but we'll talk about that later. Okay, so let's look at just the numbers. Forget about the negative for a second. Just the numbers. We have a 3 in common, so that's part of my GCF. We have an X in common. Smallest exponent is 1, but I'm going to factor out that negative. Okay, that's going to just help us later, especially in intermediate algebra. Okay, now we're going to divide by this -3x. We divide by this -3x. We get negative divided by a negative is a positive. The 3's go, but we have an x left upstairs. Positive divided by negative is a negative. Everything goes here. We have to write the 1. Here's why we have to write the 1. If I subtract 1 from you, it changes the answer. And plus, I have to be always able to get back to here by multiplication. -3x times x, -3x squared. -3x times a -1 is positive 3x. So now I can get there. Remember, we have to be attached by multiplication. That's a factor, that's a factor. This whole thing is a factor. The only terms that exist are inside the parentheses, and they have nothing in common. So we are done. This is beautiful. Okay, ready for this? All right. To do this problem, remember what we have to do. We're going to go to the lowest number, 1/7. 1/7 is the lowest number. They all have the same denominator. Okay, 1/7 is part of my GCF. Now we look for the variables. Yes, everybody has an x. Smallest exponent on the x is x cubed. So that's my GCF. Okay, now what I have to do, remember, is take each one and divide it by my GCF. So I'm going to take 1/7 x cubed here, 7th x cubed here, 1/7 x cubed here. Okay, I'm going to show you how to divide. Don't get nervous. I'm going to show you how to divide. I'm just going to erase this side of the board just for a second. Okay, so we're going to divide here. Well, 1/7 divided by 1/7, that's easy. That's just 1. X to the 5th divided by x to the 3rd is x squared. Positive. Now 5/7 divided by 1/7. Watch how nice this is. This is 5/7 times 7/1. Good night. We just get 5. So that's 5. There's an x left upstairs. Minus, again, this is just going to be 2, okay, because it's going to be 2/7 divided by 1/7, which is 2/7 times 7/1. Good night. We just get 2. I'm going to show you why that makes sense. Because do I have, oh, and that's it, and the variables go. Okay, because 1/7 x cubed times x squared is 1/7 x to the 5th. 1/7 times 5, if you put 5/1, is 5/7 x to the 4th. And then this would be -2/7 x to the 3rd. So you are done. That was absolutely beautiful. Again, you're attached by multiplication. The only terms you have are inside the parentheses, and they cannot be factored anymore. That's how you know you're done. Okay, so in this next thing in your workbook, there are some problems to make you factor some more problems. There are 3 of them, so try those, and then we'll come back and do them. All right, this was your turn, right? We look for a GCF. We start with the 4. 4 does go into both of those, so that's part of our GCF. We look for a letter. Y is in both of those, so y to the first power is part of my GCF. So that's my GCF. Once I make a GCF, I make a large set of parentheses, because now I'm going to divide each of these terms by my GCF. So now we have y minus 4 into 12 goes 3. Good night, y's. So 4y times the quantity y minus 3, and we're done. And of course, you can check that by multiplying through. And you're done there. Okay? Let's try this guy. Look at the smallest number. Oh, I made this too easy for you. Okay, 3x. Because the 3 divides into all these numbers. It's the biggest number that divides into all of them. They all have x's. Smallest x is x to the first power. Now I'm going to divide by 3x. Divide by 3x, divide by 3x, and we get 4x squared plus 2x plus 1. Yes, you need the 1, because you have to be able to multiply through and get back to here. So now remember, the difference between this first statement and this is just that it's written different. This is written as terms, simplified. This is written as factors. That's the only difference. So you're done there. Last question. Leading negative. If the leading term is negative, we're going to take it as part of our GCF. We look at the numbers 14 and 7 and see it's 7. They both have an x. Smallest x is to the first power, but they don't share a y. So that's it. Now we make a big set of parentheses. Negative divided by a negative is a positive. One of the x's go, and we get x, y, because the 7's go. We get x, y. Negative divided by a negative is a positive. 7 goes into 14 twice. Good night, x's. So now you're done. And of course, you can multiply to make sure you're correct. And that's it. Now, listen, all of these on the board, and I think a lot of the other ones we did, had a number and a variable as a GCF. You don't always have both. Sometimes you just have one variable. Sometimes you just have a number, and that's it. So I think almost all of these had a number and a variable. Okay? In a minute, we're going to take something that looks kind of weird. Okay, here's the deal. This problem, I know what you want to do. I know you want to. You want to absolutely distribute. Don't do it. Here's why. The directions say factor completely. If you multiply, you're going the wrong way, because factor is division and multiplying is the opposite of that. So do not multiply here. What you should notice is this plus sign. This plus sign tells me that this is one term, all attached by multiplication. Think of this as one thing. This is another term. So there are my two terms. I'm going to look for GCF. First thing I'm going to do is look at the numbers. Between 5 and 6, there's no GCF. Then I'm going to look at the letters outside, because the letter outside is a factor. So that x is a factor. There's no letter here outside, so there's no factors on the outside. Now, the 5's a factor, the x is a factor, so is the entire y plus 2. Here, the 6 is a factor, and so is the entire y plus 2. Well, what is a common factor here? What is a common factor is the y plus 2. They both have y plus 2. It's in parentheses. I would leave it in parentheses. That is the GCF. And once I find the GCF, I make one set of parentheses. Once I make that set of parentheses, I now divide by my GCF. When I do that, good night, right? Divide something by itself, you get 1. So I get 5x. Positive divided by a positive is a positive. Good night, I get 6. That is my answer. Y plus 2 times the quantity, 5x plus 6. Now, I have to tell you, I know I'm done because I only have factors. I know I'm done because the only terms exist are inside the parentheses. But I have to check this. I just want to show you something. Here's the check. Five xy plus 6y plus 10x plus 12. Now, that does not look like this. That right there that you were given is 5x, y plus 2, plus 6 times y plus 2. That does not look like that, but if you multiply this out, you will get that. 5xy plus 10x plus 6y plus 12. They're in a different order, but who cares because it's commutative. So it does check out. It just takes a little more checking. You absolutely need parentheses around this because without parentheses here, then the 2, the only thing multiplying this 5x plus 6 is the 2. So you absolutely need parentheses. So your entire answer is y plus 2 times the quantity y plus 2 times the quantity 5x plus 6, and you are done. That's an awesome problem, and you can check it if you feel the need. So where it says you try these, and there are 3 of those, try those 3. All right, directions are factor completely. So what didn't you do, I hope? I hope you did not multiply. So let's take a look. This is one term. This is another term separated by that minus. What they have in common, nothing on the outside of the parentheses, but they have in common this 3y minus 1. Make a big set of parentheses. Divide both terms by 3y minus 1. That means, right, that reduces to 1, and I have left here x squared, negative divided by positive is a negative 10. X squared, x minus 10. So, oh, sorry, x squared. I did say x squared, but I wrote an x. So it's the quantity 3y minus 1 times the quantity x squared minus 10. To check that, you can multiply this out and multiply this out, and you'll see it. Okay, so that's number 1. Number 2, ready? Okay, here we go. My suggestion is there's no number here. You might want to put in that 1. It might make this a little easier. Okay, this is one term. This is another term. What they have in common is 4a minus 1. It's in parentheses, leave it there. I divide both terms by 4a minus 1. Don't call them sides because they're not sides. It's not an equation or an inequality. Okay, now good night, and I have 8z minus 1. And I'm done. That's it. Pretty easy. That's pretty easy if we think about it. Just don't multiply. Everybody wants to multiply, but remember the goal. Factoring is division. Factoring is division. So don't multiply. All right. This is one term, 3 factors. This is another term, 3 bigger factors. Okay? What they have in common, no numbers outside, but they have the a plus 4 in common. Make a big set of parentheses. That may not be big enough, to be honest. Okay, so divide this by a plus 4. Divide this by a plus 4. Never divide without putting a 1 because it reduces to 1. And 3 times 1 is that 3. 2a times 1 is 2a. This side I have 2a. This side I have 3 times the quantity 2a minus 3, don't I? Look, the a plus 4 is gone, but the 3 is there, the 2a minus 3 is there, and it's attached by multiplication. You cannot have parentheses within parentheses, so we have to distribute that. A plus 4, 2a. Now I'm going to distribute that positive 3. Positive 6a minus 9. Positive 6a minus 9. Combine here. It's still not done. The question that never ends, 8a minus 9. Now, I have to tell you, you must go back into these parentheses. We haven't really had any that did that, and we still don't. But you have to go back into the parentheses. Make sure there's no GCF. No GCF, no GCF. I am done. So that's it. That's how that problem looks. That is a beauty. I love that problem. Okay, so that's how you factor with GCF method. Now, what happens if they look a little different? We'll take a look at that. Okay, this is kind of cool. There's lots of terms going on here. So let's take a look at these terms. None of them can be combined, right? Because there's no x, y, y, x, no like terms. So here's what you do. First step of factoring is look for a GCF in all your terms. That's what we've been doing. That's step 1. Okay, these rule steps never change. There's no GCF in all your terms. Okay, step 2. Write the GCF down. Well, we can't do that if there's no GCF. Step 3 is divide by the GCF. Well, we can't do that if there's no GCF. Step 4 is count your terms. 1, 2, 3, 4. There are 4 terms. Well, step 4a says if there are 4 terms, group them 2 by 2 or possibly 3 by 1. Well, we're going to group these 2 by 2. And how we're going to do that is we're going to leave them the way they sit. Sometimes you have to move them. Most of the time you don't. So don't move them unless you have to. I'm going to write that plus right down. And here's what I'm going to do. I'm going to pretend that's not even there, okay, and go to the first two terms. I'm going to look at my first two terms and factor out a GCF. Well, in my first two terms, there's no number in common, but there is a y in common. I'm going to factor out that y. So I'm going to write down the GCF, divide by it, right? And I get 7x plus 2. Okay, there's the plus, all good. Now we're going to do the same thing between these two terms. We're going to factor out a GCF. The GCF is a. Make a big set of parentheses. It's what we do when we get a GCF. Write it down, make a big set of parentheses. Divide by a. We get 7x plus 2. Now the question is, are we done? And the answer is, no way. And there's two reasons why we're not done. One way is we're not even factors yet. There's a plus there. This is a term. This is a term because there's a plus there. This is a term. So one thing is we don't even have factors. How can we be done? The second reason is because we have a common factor. And the common factor is the 7x plus 2. So notice we took a GCF out of here, a GCF out of here. Now we're going to take a GCF out of the whole thing. So this is just the GCF method like 3 times. Okay? So we're going to take that 7x plus 2. That's my GCF. That's nice. Oh, I thought that was a different color, wasn't it? Okay. And we're going to now divide by it. And we have left y plus a. We're done. Y plus a. Now here's the good news. After every step, we should be able to get back to the step before us. So y times 7x is 7xy. Y times positive 2 is positive 2y. Plus 7ax, or xa, plus 2a. And then, of course, if you multiply this times this, you're going to get back to the beginning. So you should always be able to get back to where you started every single time. Now, be very careful. If this was a negative, you'd bring down a negative here, and you'd be dividing by a negative a. Be very, very, very sign conscious. So let's try another one. All right, let's go. Let's see what we got here. Well, oh, I don't want to skip. Step 1, look for a GCF in all your terms. Nope, because there's no number in common, because this is the smallest number, 2, but 2 doesn't go into 3, so there's no number in common. There's no letter in common because 12 doesn't have a letter. So that's step 1. Don't have a GCF. So can't do step 2, which says write it down. Can't do step 3, which says divide by it. Go to step 4, count your terms, 1, 2, 3, 4. Step 4a says if there's 4 terms, group them. So we're going to group them. If we group them 2 by 2, which we're going to do, 2 by 2, the animals, 2 by 2, oh, sorry. Okay, we bring that middle sign down, that's a negative, and now we're going to group these two together. We're going to look at just the 2ab and the 8a, and they have a 2 in common, and they also have an a in common. Now we're going to make a big set of parentheses, and we're going to divide by 2a to both those terms. When we do that, we get b plus 4. b plus 4. Now, I need you to be really, really, really careful here. Here's why. Okay, we have this negative here, but they have a 3 in common. There's no b in common, but it's a 3. But this is a negative 3. So when we divide, we're dividing by the negative 3. Don't lose sight of your sign. A negative divided by a negative is a positive b. A negative divided by a negative is a positive 4. And listen, we could check that. Multiply through, you'll get back here. Okay? Now, we are not done for 2 very good reasons. The biggest reason right now is the fact that we're not even factors, because we have a terms, because that minus sign. So this is a term, and this is a term. So now what we need to do, now don't multiply that, you'll get back there. Now what we need to do is look for a GCF again if they have one. Well, they do. The b plus 4 is my GCF. It's in parentheses, I'll keep it there. Make a big set of parentheses, divide by that b plus 4. And we get 2a minus 3. 2a minus 3. So these are my factors. Absolutely awesome. And that's how that works. Okay? So I hope you did okay. I think the hardest part of that is that silly negative so that you remember to change your signs in there. Okay, let's take a look at this one. Oh, it is a lot of 3's. First step of factoring is look for a GCF in all your terms. We have one. Yeah, buddy, we have one. So take out the 3, divide each one by 3. Each one by 3. Oh, do we have anything else in common? Didn't even look. No x's in common, no y's in common. So now we have x squared minus x plus xy minus y. So now, here's what we're going to do. We go inside. We have 4 terms. We go through the same steps again. You are kidding me. Okay. We look for a GCF between all of them. No. We got to go to step 4. Step 4 says count your terms. There are 4 of them. We have to look for a GCF. Okay. Now, here's how this works. I'm going to bring the plus down. Okay. There's in here, right here, the first 2, there's an x in common. We divide by x, we get x minus 1. Okay? Here, there's a y in common. We divide by y, we get x minus 1. Now, are we done? No, we're not done. We are not done here. So here's what we're going to do. In fact, what you might want to do here is, because remember that 3. I didn't pull that 3 down. I forget that a lot. Be careful. Don't forget that 3. I'm going to put it in brackets because now I'm still going to be inside here, but that 3 has to come down. We'll talk about why in a minute. Okay. Inside here, okay, we have an x minus 1 in common. So we have an x minus 1. We divide each by, x minus 1. I said 1. I wrote y. Okay. Divide by x minus 1. And you're writing this as you go, okay? And we get x plus y. Okay, so our final answer is this. Ready? Our final answer is, I'll get that smudge off the board for you, 3 times the quantity x minus 1 times the quantity x plus y. Do we really need that 3 outside? Well, you tell me what you think. Remember the goal, to get back to that. Without the 3, we're never going to get back to that, because this times this will get me to x squared minus x plus xy minus y, but I need the 3 to get me back to the beginning. So that's your GCF. That's your factor. Those are your factors. There's 3 of them. That's how you do it by the GCF method. Okay, and that was a little hard because there was a GCF method in all of them, a GCF in all of them. Okay, so that was a little hard. If you just remember to bring the 3 in at the end, you can do that also, but I never do, so I like to keep it up there. Okay, ready? Let's see what we can do about this guy. Step 1, GCF. Nope, it's got to be all of them. Nope. Step 2 can't do, step 3 can't do, step 4, count your terms. Yes, I know there are 4. So we're going to try grouping them 2 by 2. Okay. I'm going to put the plus down, and we get, ready, first 2, we have x squared. We divide by x squared, and we get x plus 2. Feeling good so far? Here, we get a 3, and we get x plus 3. Okay. Are we done? No, we don't even have factors. We have terms. This is a term, and this is a term. Okay. Do your terms have any GCF? The answer is no. This answer is prime, because this cannot be factored. I cannot write them as a product of factors because, look, these don't match. No common factors. Sometimes I could try to move these, but even if you move them, this is not going to work. Okay, so you're done. I'm going to show you one in a second that you're going to have to move to do. But this isn't even going to work if you move them. Okay, so try them first the way they sit, and this blatantly is not going to work. So you are done. That is prime. No factors. Okay, so let's look at number 4. Okay, this one gives me a rash. I'm going to tell you why this one gives me a rash. This one gives me a rash because we really like to see the constant term last. That's one thing. The other reason this one gives me the rash is if I try, I see there's no GCF. So I got to go to step 4, which is count your terms, and there are 4 of them, and I have to group them. But they have nothing in common. but they look like they have something in common, and they look like they have something in common. So I'm going to rewrite these. Sometimes they don't work the way they sit, but they'll work if we rewrite them. So I'm going to try that. So I'm going to keep 7ax where it is, then negative 7x, then minus 2a, then plus 2. And the reason I put the 2 at the end is because the constant term really generally will work if it's at the end. Okay? That's the way we always see it, standard form kind of thing. Okay, so here we go. Let's see if this helps us. Bring the negative down. First two terms. These are the last two terms. We're going to find a GCF here. We do. We have 7x. Awesome. That seems, oh, that's not a different color. Come on now. And that's a minus 1. Now we take out a 2, but it is a negative 2. Be careful. Negative 2. Be careful. Negative divided by negative is a positive a. Positive divided by negative is a negative. 2 divided by 2 is 1. Oh, that's beautiful to me. Absolutely. Hey, the birds are singing in the sky. Now I'm not done because we still have terms. But I look for a GCF, and I have one. A minus 1 is my GCF. I make a big set of parentheses. Divide by a minus 1. And I get 7x minus 2. And I guarantee if you multiply this out, you will get what you need to get, which is this guy up here. In any order. It doesn't matter the order, remember. And that's it. That's how you factor 4 terms. So sometimes they're prime, sometimes you have to move them around. 99% of the time, they will be okay, especially in this course. They will be okay exactly the way they sit if they factor. Okay? So I'm going to let you try a couple, and then we're done with factoring by the GCF method. All right, let's see how you did. Here we go. So, step 1, look for a GCF in all your terms. No. Step 2 can't do, step 3 can't do, step 4, count your terms. 1, 2, 3, 4. 4 terms, group them 2 by 2. Now listen, I know you're going, I know already. But we're going to learn how to factor other things in the next couple of sections. You're going to have to keep going over those same steps. I know it's annoying. And if my voice is annoying, that means you remember it. That is awesome. I'll wake you up in the middle of the night. Here we go. So see this sign? That comes down. All right, we look at these two. That's 2 terms, and that's 2 terms. Here we go. GCF of the first 2 is just a plain b. We divide by b, and we get 3x minus 2. So far, I hope you're good. Next one, GCF is 5. Divide by 5, and we get 3. Feeling good still? 3x minus 2. Feeling good. Okay, now, this is one term, this is another. Look for a GCF, and yes, I have a GCF. It is 3x minus 2. I make a big set of parentheses after I have my GCF. That step never changes. My GCF may look different, but that step never changes. Write down the GCF and make a big set of parentheses. And I get b plus 5. So my answer is the quantity 3x minus 2 times the quantity of b plus 5, and I am done. And if I want to check it, I multiply these two, and I will get this thing I started with. Awesome. Hope that went good for you. Let's try 2. Okay, number 2. Look for a GCF in all your terms. Nope. This 3y kind of makes it not happen. Okay? There's an 8 there. 3 doesn't go into 8. No numbers go into all of those. X's, they don't all have X's. They don't all have Y's. So, all right. Now, count our terms. There are 4. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to group them. Here's the issue. Rash. You called it. I have a damn rash. Here's why I have a rash. Okay? This is a constant term. I really would like that at the end. Now, that may not work, but it works most of the time. And plus, these have nothing in common, so I'm getting a rash. Because these two have nothing in common. So I'm going to kind of move this around. Now, you have a couple of choices, I would think. Because these two have common factors. These two have, you could choose. And it may not work on the first shot, so I don't know if it worked for you. But I'm going to try this. You ready? 2xy minus, I'm afraid, 8x minus 3y plus 12, because I could have switched those. I'm afraid. We'll see what happens. Here we go. Sometimes it works more than one way. Okay, here we go. Look at that middle sign. Where's my blue marker? I think I ate my blue marker. Oh, it's in my hand. Oh, no. It's in my hand. Okay, here we go. GCF is 2x. Make a big set of parentheses. Divide by 2x. We get y minus 4. Okay, I think we got a winner, chicken dinner. Here we go. There's a 3 in common here. We make a big set of parentheses, but it is a negative 3. Negative 3. Negative divided by negative is a positive y. Positive divided by negative is a negative 4. Yes! All right, there's the deal. Okay, now we still have 2 terms. This is a term, and this is a term. We look for the GCF. The GCF is y minus 4. We make a big set of parentheses. Okay, already. Big set of parentheses. Divide by y minus 4. And we get 2x minus 3. I'm feeling so good about that problem. I'm loving it. Awesome. That was number 2. Ready for number 3? Oh, number 3. Oh, okay. Let's do number 3. Looks like a good one. I have to tell you that if you don't find the GCF at the beginning, you can find it at the end, but most people forget to take it out. So I like to take it out at the beginning. There is a GCF of all of these terms. It is? Yes, 4. Okay, here we go. xy minus y plus, oh, sorry, divided by 4, divided by 4, divided by 4, divided by 4. Okay. Plus 3x minus 3. Okay, now we go in here. Remember, we cannot have any common factors, or we cannot be able to factor any more, okay? So we look, there's no GCF, but now we have 4 terms. See, here's the problem with this. Every time you get a set of parentheses left, every time you learn a new way to factor, you have to keep checking. It's a little annoying. Okay, so I go in here, I have 4 terms. And I'm going to have to try to group them. So I don't want to lose sight of my 4, so I'm going to start like this. Make a big bracket. Okay, here we go. Put my plus down. I have a y in common. I divide by y. I get x minus 1. Here I have a 3 in common. I divide by, oh, I'm feeling so good right now. X minus 1. Okay, here we go. Keeping that 4. 4 is going to get ticked if you lose him. I'm looking at this term and this term because they are terms because they have plus. You got to know the difference between terms and factors, or I have to tell you blatantly, you're screwed. Because there's so many things that happen just that can work for factors that do not work for terms, and vice versa. So here we go. X minus 1 is our common factor. We make a big set of parentheses. We divide by x minus 1, and we get y plus 3. And now I can just write it like this. This is absolutely equivalent to what's above. And I am absolutely, absolutely done. Okay, let's do problem 4. All right, step 1, look for a GCF in all your terms. Okay, step 2, can't do. Step 3, can't do. Step 4, count your terms. I know. 1, 2, 3, 4. 4 terms. 1, 2, 3, 4. 4 terms. You go to step 4a, which says group them. Okay, so we're going to try to group them 2 by 2. We're going to bring this plus down. Okay, now here we go. Ready? Okay, first 2 terms has a GCF of 7x squared. 7x squared is my GCF. If you're not sure why that's your GCF, let's talk about it. 7 goes in here, goes into 21, and x squared is a common factor, and that's the lowest exponent you see. Okay, so divide by 7x squared, divide by 7x squared, and you get x minus 3. So cool. Now, let's bring down the 2. Let's take out the GCF. GCF is 2. Divide by 2, and we get x plus 3. You see a problem? Because I'm starting to get a rash. Okay, here comes the rash. It's growing. Because I'm not done, because there's terms, but here's the problem. There is no GCF anymore, so I can't do anymore. This is not the answer. These are not factors. That's why it's not the answer. So this is prime because it has no GCF left, so I cannot write them as factors. I am done. It is prime. We are done with factoring by the GCF method. We are now going to learn how to factor trinomials.